everyone's having a good day so far. All right, here we go. Yesterday, here's what I gave you yesterday. I said, all right, guys, here's the center of dilation. Here's the scale factor dilated. And everyone did a great job with that. Here's what I'm going to do for the first half of today. I'll give you both points now. What was my scale factor? All right, so now you guys provide me with the scale factor. And if you read through the directions here, point R is the image of A. So I started with A, 3, 4. I'm telling you I did a dilation. We did a dilation, and I went to 9, 12. What was my scale factor? Well, I don't want you to guess here, but good news. Keep reading the directions. We're dilating with the center at the origin. That means I can do my shortcut, can I, if I choose to do so? And what was my shortcut yesterday? Multiply the scale factor with the coordinates. Multiply the coordinates by the scale factor. All right, so if I approach number 1 right now, I just got a quick question for somebody here. Taylor, what's in point A, what's my x coordinate? 3. And what's my x coordinate in the image, point R? 9. So here's what I'm telling, right? Because we're dilating around the center, I multiplied 3 by the scale factor, which we call K, and got 9. And did I need to set that up? Probably not. I'm sure we could have looked at it. And the same thing goes with 4. I multiplied it by the same scale factor and got 12. Right? I get it. We could have all just looked at that and known the scale factor is going to be 3, but sometimes it's not obvious. So I'd like to see you set up a little equation like that if it's not obvious. Speaking of not obvious, number 2 is not obvious. All right, number 2 is not obvious here. What's my scale factor? Let's go, Zoe here. What's my x coordinate of A? 9, and how about the x coordinate of R? Okay, that's not easy for me. That's not obvious here. All right, so that's why it's nice to set up, hey, 9 times what will give me 6, or 12 times what will give me 8. All right, so if it's not obvious, set yourself up a quick equation and solve for K. And you definitely leave it as a fraction here. I don't want that repeating decimal. What is my scale factor here? Going here. Yep, I'll get to you, Keating. 2/3, yep. So it looks like these points are getting closer to the origin. All right, go ahead and try number 3. I don't need to hold your hand on that one. All right, Alex, what do you have? What's my scale factor here? 5, good. All right, all good. Questions on given points, finding the scale factor. And as you guys look below in your notes, now we're going to, given the 2 figures, can you find the scale factor? All right, given the 2 figures. I am going to show you 2 different methods. You pick which one is you're most comfortable with. All right, I just don't want to say one method, do it this way. All right, key component here. Make sure we understand that B is the image. All right, B is the image and A is the pre-image here. But good news again, guess where we're dilating? Around the center. All right, let's go to number 4 here. So what did I multiply by? What was my scale factor to get from A to B? First way to do it, because we are centered at the origin, here's the first way to do it, is I take any point from the pre-image, which would be, let's see on here, that's -1, 2, -3, -3. And make sure you pick its corresponding point on the image, which for us would be right here, -1, -1. And now this turns into a problem we just did before up top of your notes. Right? Just make sure you know that A is my pre-image and B is my image. So now I'm saying -3 times my scale factor equals -1. Or you could do it for the y coordinates, which is the same exact thing, -3 and -1. Understand why it's so important to know where the image and the pre-image are. Because if it's reversed, those numbers are interchanged. So what's my scale factor for this one here when you're ready, Mia? Positive 1/3, good. And then, hey, that starts to make sense a little bit because what did we talk about yesterday? Scale factor between 0 and 1. Points get closer or further away? Closer. So that's why it's 1/3 and not 3. 3, they'd be getting further away. I said there was a second way I'd show you. The second way is if you can find the lengths of two corresponding sides. Watch. I believe we can find the length of this without doing distance. We can count 1, 2, 3, 4, 5, 6. Everybody's good? Its corresponding side is 2. That'll tell you the scale factor. Now the question is, do I go 6/2 or 2/6? You guys just answered that for me before. Am I getting smaller or bigger? I'm getting smaller from A to B, so it's got to be 2/6 versus 6/2. And that's another way you could get the scale factor. Okay, so you can pick the points off and do it the way we did above, or you can measure the length of two sides and find the scale factor that way. Go ahead on parts numbers 5 and 6 on your own. Remember, you're going from A to B, A to B. So in your mind, you should say, scale factor is going to be bigger than 1, or it's going to be between 0 and 1. You find it any way you want. I just gave you 2 methods up here. Okay. Number 5, before I call on somebody, let's make sure our scale factor should be bigger than 1, right? It should be bigger than 1 because I'm getting further away from the origin and the diagram's getting bigger from A to B. So hopefully it is bigger than 1 here. A little help here. Where am I going with that one? 5, 5. I give up sometimes. I do. I'm awful. Sydney at this. What's that? Yeah. 2.5, 5 halves. I'm good with either one. Yep. 2.5 or 5 halves. Looks good to me. Then how about 6? Let's take a quick peek before I call on somebody. A to B, I should have a scale factor between 0 and 1 here because I'm getting smaller and closer to the origin. All right, so I should have a scale factor between 0 and 1 there. 1, 4. Keating. 1/3. 1/3 it is. Yep, 1/3. Any issues? Finding the scale factor. So now, Mia?
I know that it's like around the origin, but on 5, why is like the 1 over there?
Say that again?
Like, I know it's around the origin, but
Yep.
like for 5, the 1 is like over more. So what?
No. This one?
No, the other one.
Oh, that's a good call. I didn't notice that. 1, 2, 3, 4. Yeah, I guess maybe they're going by 0.25s now. I didn't notice that. Good notice. All right, I won't do that to you. Okay, yeah, we'll stick with the 1 right there. That's respect right there. Respect. Good job. I didn't see that. Good. So probably, yeah, they're going, actually, this would be 0.25, right? Yeah. Nice job. Everyone see what she was saying there? It's not going by ones, it's going by two. I'll have to change that next year. Thank you. Any other questions? Good job. All right, one more before we go to the constructions. I got ABC, and then I have A prime, B prime, C prime. Describe the transformation that just happened. Hey, we know it's got to be a what? We've done 4. Reflection, translations, rotations, dilations. Look at this thing. It's getting bigger. So at least we know we've done a what? A dilation. But I'm sure you guys can guess that word alone is not going to cut it. What do I always need 2 things if you're going to tell me a dilation is happening. What are the 2 things you always need to do a dilation? The what? Scale factor and the center. Yep, the center and the scale factor. I always just assume, here's how I go. I always assume it's the center, but I check if it's the center or not. How do I know if it's going to be the center or the origin is going to be the center or not? Here you go, ready? Let's take point A. -2, 1, 2, 3, 4 is -2, 4. And then I go to A prime. Let's see, what's that bad boy? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Wow. That was a counting. -5, 10. Am I multiplying the x and the y by the same number to get its image? If I am, great, but that doesn't make me a winner. I'm going to have to do it from B to B prime as well. -2, -4. So this is how I check if the center of dilation is the origin or not, which honestly in here, it'll probably be the origin. Right? I'm not going to try to trick you, and the center will be like 5, 1. What's this one? -5, -10 for B prime. All right. So number 1 is figure out if you multiply everything by the same number. And then if you do, let me know what that number is, because that's your scale factor. So hopefully you're finding out it is centered at the origin. So dilation. It's a dilation centered at the origin. And now I just need the scale factor. And hopefully your scale factor is bigger than 1, because I'm looking at points that are getting further away from the origin. Dilation centered at the origin with the scale factor of, what'd you find with the scale factor, Keating? 2.5. 2.5 or 5 halves, yep. Yep. If you didn't want to, again, if you didn't want to do that, remember you can always count the length of 2 corresponding sides, and that'll give you the scale factor. All right. All right. Last part before we pick up the compass and straight edge. Explain why these are similar. Time travel a couple days back. You guys did a great job with proving figures congruent. Remember, you told me there were translations and rotations, and there were rigid motions. Remember writing all in the blanks there? We all remember writing in the blanks a little bit? We will for Tuesday's test, huh? All right, well, now we're doing similar. So let's go through there. Can we say dilations are rigid motions? No, we can't say that. That's false. Dilations are not rigid motions. They change side length. Can we say dilations preserve side length? Nope, can't do that. But we can say, ready? Here's where we're going to actually start. I can't say all that stuff I started with because it's false. But we can say they don't preserve side length, but they do preserve what? Angle measure. Perfect. You guys got it. So we're going to say dilations preserve angle measure. And then whatever word, I'm not going to Google it again, but whatever word you would like here, thus, ergo, consequently, henceforth, therefore. Make sure you put the similar sign and not congruent. And maybe I haven't sold you yet on why they're actually similar. Go back to our similar triangle unit. This would be huge if you can dig this up. I gave you 3 reasons, actually 3.5 reasons to prove triangles similar. And remember the top method? Angle, angle. If they preserve angle measurements, I got angle, angle. So that's why they're similar. All right. All right, any questions finding the scale factor? We're good? Time to pick up our compass and straight edge. And I got news for you. I'm not going to show you anything new here today. All right, I've shown you a lot of constructions this year, but this is not a new one. So let's bust it out here, make sure it's ready to roll, nice and sturdy. You got a straight edge too that you'll need. All right, let's talk here. Let's talk. A little conversation here. Rayan, how are you doing today?
Good.
I'm doing well. Thank you for asking. And that was nice of you. Where's the center for this problem? Where are we dilating around? Oh, yeah. What's the scale factor?
1/2.
Okay, so from everything I've shown you or tried to show you, are A, R, and T going to get closer or further away from O?
Closer.
Everyone agree. They're going to get closer. How much closer? Half the distance. Okay. Right now, A, R, and T have a certain distance away from O, and we're going to cut that distance in half. In half. So let's do it for point R first. R has a certain distance from O. Everyone agrees? And you're going to show me that distance right now by drawing a segment from R to O. So take your straight edge. Draw a segment from R to O that represents its distance. This is how far R is from O. And what are we going to do with that distance? What's my scale factor? 1/2. We're going to cut it in half. Do I have any constructions I've ever shown you that cuts a line segment in half? There we go. This is the most probably one we use the most is our perpendicular bisector, where we put our compass point on one of the endpoints. You guys finish the story now. Open it up. More than half the length. Perfect. And this is where we make our half circle sized arc. And we keep our compass opening the same. And we travel to the other endpoint of the segment. Please do not try to get ahead of me here because I'm going to save you a little frustration. And make sure it intersects in not 1, but 2 spots. Now, I want you to think, we're going to have to do this 2 more times on A and T, 2 more times. So everyone agree that's a lot of arc marks flying around. All right, and I don't know about you, but that makes me nuts. All right, with all these arc marks, I forget what arc belongs with what point. So grab your straight edge right now, line it up, but don't draw anything in. Line it up. Line up your straight edge with those 2 points of intersection you just made. But, hey, you tell me, do I really need that line drawn in? No, I don't need the perpendicular bisector drawn in. It's just going to be an extra line. What I need to know is where it's going to intersect RO. So just line it up and make a little marking where it intersects. I don't need that full line there. It's just going to be more mess. And there is R prime. Halfway closer, just like we predicted. All right, we wanted to move R halfway closer. Okay, here we go. Now we got to do it from T to O and A to O. So I'll let you guys roll on your own now. I'll finish mine and then come around and help you guys out. So you decide T to O, A to O. cut the distance in half. Hopefully you got a smaller triangle that's closer to O. Good, everyone. Good work. Good work. Oh, darn right, we're making a triangle. Right? We're making a triangle. It says dilate the triangle, just not the points. You want to show off your greatness here. Do you need to shade it in like I did? No, you don't, but that's just what they told me to do in teaching school, so kids can see it. All right, any issues with the 1/2 before I go bigger than 1 now? Oh, let's do this. Another one I'm not gonna teach you, I've already shown you probably. Vroom! All right. Talk to somebody here. 1 zip. Jesse, what's good, man? How you doing? Good. I'm doing all right today. Good day. All right, couple questions for you, Jesse. Where's my center of dilation here?
At B.
At B. So guess what's not going to move? You're welcome. B's not moving. We can just call that B prime right now. All right, because that's the center. Thanks, Jesse. And then what's my scale factor here, Jesse?
2.
So when I move A and C, are they going to get closer to B or further away? All right, everyone ready to go? It's going to get further away, doubling its distance right now. So wherever A is, make sure it doesn't go on the other side. It's going to get somewhere on top here. And I got to double that distance right now, double it. So take your straight edge right now. Here's how we're going to start. Extend BA for me. Extend BA. And we've already said, since the scale factor's 2, we're going to double that distance. Well, find the distance right now. Take your compass. Find the distance from B to A, because I need to double that distance. from B to A, measure that distance. So it can be doubled. All right, what do you guys think? How am I going to double that distance? I don't need an arc mark there. I just need to measure the distance. How do you double it? Move it up to point A. There you go. I just doubled it. And make yourself a little arc mark. And you just found A prime. Bam. And let's double our distance from B to C now. Extend BC. Measure the distance from B to C. And you guys go ahead and double that. And you'll notice a bigger looking triangle on your hands. And finally, are these two triangles similar? Yes, they are. And why? Jesse, what did we just perform? A dilation. Dilations. Don't tell me they're rigid motions. That's false. Don't tell me they preserve side length. That's false. We know they preserve angle measure. I'm going to go henceforth here. Feeling like a boss right now. Henceforth, triangle ABC. Just be careful. Make sure you write the similar sign. A prime, B prime, C prime. Alrighty. What a session right there. What a session. Remember, dilations only preserve angle measure. That is it. Angles are congruent. Nothing else. Nothing else.